Swayam Prabha. Digital India. Educated India.
Welcome to the fourth lecture in mechanics of materials. In the last class we saw about how a vector can be transformed due to a transformation of basis vectors, and then we saw that force is a vector, and we saw how we infer that force is a vector through an experiment. So, coming back to the concepts and relations in mechanics, there are four concepts which we are used in mechanics, which are force, displacement, strain and stress. Of this we have looked at one concept which was force. Today we will look at the other concept which is the displacement. To understand displacement, you should understand how we model body in mechanics. So, let us look at what body is. What is a body? How is it idealized in mechanics? For us, body is a collection of ordered, countable or countless particles. First, here there are two keywords, one is ordered and the other one is countable or countless. We have to understand what they mean next. What do you mean by ordered? A set is said to be ordered if you can establish that one element is before or after the other element, or there is an order to in the way in which the elements of the set are arranged. For example, let us consider 5 points. One, 2, 3, 4 and 5. We can say the position of points two to 5 with respect to the point 1, right. We can say the point 2 is above point 1, you can say that point 2 is above point 1, point 3 is to the right of point 1, point 5 is to the left of point 1 and point 4 is below point 1. Similarly, you can say that there is a point 6 which is in front of point 1 or point 7 which is behind the point 1. Okay. So, likewise you can say that these points have a relationship between them, which is what ordering of the points mean. Okay. That is, the particles in the body have an order, meaning that they have a relationship between them in front of, behind, top, bottom, right or left. Okay. So, that is what we mean by an ordered set of particles. Next, to understand what is the difference between countable and countless. Countable means it can be set of integers from say 1 to 10,000. You can count the number of integers from 1 to 10,000, but you cannot count the set of real numbers from say 0 to 1. This is an example of a countless set. Okay. A set of integers itself is also a countable set, just like set of real numbers alone is also a countless set. That is, you can't isolate one number or one element of the set. Okay. For example, if you think of set of rational numbers, you have 2 by 3 or 1 by 3 alone as rational numbers, the ratio of two integers alone a rational number, but there exists a irrational number between any two rational numbers, and hence real numbers is a countless set, whereas set of rational numbers or irrational numbers are countable set, even though the number of elements in that set might be infinite. Okay. So, there is a difference between infinity, countable and countless, which you have to remember. So, a body is said to be a collection of countable or countless particles. Where this countable or countless comes is whether you are assuming a body as a discrete, made of discrete particles, or whether you are assuming it as a continuum. Okay. So, if it is countable, the body is said to be discrete, and if it is countless, the body is said to be a continuum. These assumptions of discrete or continuum is for convenience sake. For example, when you want to find the strain or when you want to find the gradient of displacement, I have to be able to take the derivatives. Then I can't leave the elements of a set when I take the do the limiting process, and hence you assume in those cases the body to be a continuum. In this course, since you are assuming the body as deformable bodies and you want to compute the changes in length along any direction for any length of the line element, we are going to take derivatives of the displacement field. Hence, we assume that the body is a continuum or is made of countless number of particles. So, in particular we will model it as a set of 3 real numbers. A body consisting body will be mapped onto a set of 3 real numbers. Okay. So, this is a physical representation of the body. Okay. So, now we understood that body is a ordered set of particles which may be countable or countless. Now, how do you represent a body mathematically is using a Cartesian set notation, wherein this body B would be written as a Cartesian set of 3 real numbers x, y and z, 0 less than x less than 1, 0 less than y less than 1, 0 less than z less than 1. If I am thinking of body to be a cube, centered above with one of the corner points at the origin. Okay. So, with the one of the corner points at the origin, if this is 0, this is 1, this also say I am not drawing it to scale, say this also is 1, this represents this body. On the other hand, I can write another body B star as same Cartesian set of x belonging to 0 1, y belonging to 0 1 and z belonging to 0 1. What this means is, this means the 8 corner points of the cube, namely 0 0 0, 1 0 0, 0 1 0, 1 1 0, 0 0 1, 1 0 1, 0 1 1, 1 1 1. So, I have 8 points here. So, this body would be, this would be Z x and y, it will be these points. It will be these points. Okay, it will be the corner points of the cube alone is this body B star. Okay. So, what is the meaning of this notation is, I take one element from the set x, one element from the set y, one element from the set z and form this 3 elements x, y and z. That is, I take one element from the set x, one element from the set y, one element from the set z and form this set which is one element from x, y and z and form all permutation combinations of all the elements in those 3 sets. That is what the meaning of this Cartesian set means. Here it is discrete because elements of x, y and z are integers having values only 0 or 1, whereas here it is continuous wherein can take any number from 0 to 1 for x, y and z. So, in this case this entire region is what the body is, all this region is the entire region occupied by a cube is what this body represents. Okay. This is an example of countable set, a discrete representation of body. This is an example of countless set, a continuum representation of the body. Okay. So, now how many particles are there in this countless set? Infinity of them. Now, say I apply a force and this body elongates into some other region. For example, let us say this body elongates to occupy this green region. Okay, body expanded to occupy this region. Now, then I will represent this green body as a Cartesian set of x comma y comma z, where x varies from, it still varies from 0 less than or equal to x less than or equal to 1.5 say, y varies from 0 less than y less than or equal to 0.9 say, and z 0 less than z less than or equal to 0.9. Okay. Now, we will say that the mapping between this B and this B, let us say this is beta bar, we will say the mapping between beta and beta bar is 1 to 1. You should not get confused that if it is 1 to 1, how does the volume preservation and all those things happen. Okay. The volume is not preserved clearly in this deformation. What was a unit cube now becomes a cube of volume 0.81 into 1.5. Okay. So, what we mean by a 1 to 1 mapping is not that each particle gets mapped on, each element of the set gets mapped on to a one element in the range of the mapping. Okay. But it is not that, it is, you have to recognize the difference between a countable and a countless set. In a countable set, I will say that if this body is mapped on to there, this 0 0 maps on to 0 comma 0 comma 0, this will map on to 1.5 comma 0 comma 0 and so on, and it is only those points that gets displaced. On the other hand, when it is a countless set, every point gets displaced in the body. It is not that the volume will be preserved in such a mapping even though the mapping is 1 to 1. Okay. That is because these are two infinities, you can't compare the two infinities mathematically in a precise manner. Okay. Okay. So, now we understood what a body is. Now, let us understand two configurations of a body, that is I assign at a particular time, I find what is the length of the body, what is its cross sectional area, where are its particles and so on, and then I apply a load, the body deforms and then it goes to some other configuration. Okay. For example, the green body that I showed in this example is after application of a force, this is one configuration, and the black body beta is another configuration. Okay. So, we will assign names for these configurations.